वो एक और एग्जांपल कर लेते हैं कि अबाउट reactions. ठीक है, for example, I'm going to try and write the reaction of FeCl3. नहीं, FeCl2. I minus one क्या था? Oxidizing agent होता था, reducing agent था. So I'm going to write an अच्छा I'm going to anyways I'm going to write an equation of FeCl3 with KI. Social right second like with KI aqueous. ठीक है, अच्छा sorry, this is we're just doing a recap. ठीक है, remember what we did last time? Okay, we tried to figure out whether the redox reaction will happen or not. ठीक है, so इसमें बस एक चीज में देख लो कि चलो let's try and see whether there's going to be a reaction or not. ठीक है, अच्छा, the first thing you have to identify the reagents that are in this. So you've got Fe3. Going to try and write down all electrode reactions involving these. ठीक है, all of the electrode reactions that involve these four substances. So if you look at the data booklet, so Fe3 plus is involved in this equation where it's in equilibrium with FeCl with Fe2 plus, and that is the E naught is 0.77. ठीक है, and then you have मैं वो शो करना चाहूँ कि कभी कभार ना there might not be a reaction. ठीक है, अच्छा, then there is Cl2 Cl minus 1. So Cl minus 1 is in this electrode, so we're just going to copy that reaction. So this reaction is going to give you 2Cl minus 1, and the E naught for this is 1.36 volts. So then I have K plus 1, so the electrode is, this is in equilibrium with the, it's in equilibrium with the K, and this E naught has a value of minus 2.92 volts. And I've got I minus 1, so there's an electrode where it's in equilibrium with the I2, and the electrode value E naught is, I think it is 0.54 volts. Okay, so I think it's 0. I think it's 0.54. Let me just double check this. Okay. Iodine का क्या है? Iodine, let me just have a look at the data booklet. Iodine is पता नहीं कहाँ गायब हो गया, iodine किधर गया? अच्छा, iodine is yeah, it is 0.54. अच्छा, Fe3 plus has one more reaction. So there's one more reaction that involves Fe3 plus, and that is Fe3 plus can gain 3 electrons. And it could form Fe. Okay, it could form Fe, and the E naught for that is, okay, E naught is Fe3 plus 3 electrons. That's minus 0.04. Okay, that is minus 0.04. अच्छा, so remember, okay, I'm just going to do a quick recap. Okay, recap क्या था कि what happens is कि when you have an electrode, when you're trying to figure out a reaction, just like यहाँ पे in this case we are trying to figure out the reaction between FeCl3 and Ki. So pehla step number 1 is that you are going to figure out what your reagents are. Okay, so Fe3 plus Cl minus 1, K plus 1, and I minus 1. Someone out of these would be gaining electrons. And then list of reactions, electrode reactions would be given. So you're going to try and find out all the reactions that involve Fe3 plus or Cl minus 1 or K plus 1 or I minus 1, right? And then you're going to try and figure out what the reaction is. Out of all of these possible electrode reactions, who's going to gain electrons, who's going to lose electrons? So the rule is that the highest potential is the one that gains electrons. Now, out of all of these, the highest potential is for 1.36. So this is the one that's going to gain electrons. But the issue is, the issue is that it will not be able to gain electrons because it is Cl2 that gains electrons. Or यहाँ पे ना over here there is no Cl2. I mean you don't see any Cl2 over here. So which is why this reaction is not applicable. इसको हटा दो to lose your highest potential. That's 0.77. This is your highest potential. This is the one that's going to gain electrons. And so Fe3 plus is going to gain electrons, and we obviously do have Fe3 plus as a reagent. So there's absolutely nothing wrong with this. So I figured out okay, the highest potential belongs to this one. It's Fe3 plus, and that is the one that has the greatest tendency to actually gain electrons. ठीक है सारा वो clear है ये? Ibrahim, Hala, Vanya, Minal, is this
Yes,
clear?
sir.
Yes.
अच्छा फिर बाकी सारों में से I have to figure out who loses electrons, right? The one that has the lowest potential loses electrons at the moment. Lowest क्या minus 2.92. So that is the one that loses electrons. लेकिन if that loses electrons, it's potassium that loses electrons, and I don't have any potassium. I have potassium plus one, but I don't have potassium, the atom, right? So which is why I'm going to get rid of this. If I remove that, who's the lowest potential? It's 0.04. And it's Fe that has the greatest tendency to lose electrons, but obviously we don't have any Fe as well. Fe3 plus, we don't have Fe. And if I remove that, the lowest potential belongs to I minus 1. So I minus 1 is the one that loses electrons. Or TK, I have I minus 1 in my reagents. So this is the one that I'm going to select for oxidation when it comes to losing electrons. अब फिर दोनों को combine करना. I just need to combine both of them to make the overall redox reaction. The only thing I need to do is I need to balance the number of electrons. So the top one I'm going to multiply it by 2. Or reactant startup kar lo. And on the other side, I'm going to write the products. So the reactants are, in the first one, it's 2Fe3 plus. In the second one, the reactant is 2I minus 1. And the product is, upar wale mein it's 2Fe2 plus that's forming. In the bottom one, it's iodine that's forming, right? That's my overall equation. Okay, so that's my overall equation. And we can have the E naught cell for this as well, which is the reduction E naught minus the oxidation E naught. So higher potential minus lower potential, basically. So it's reduction is 0.77 and oxidation is 0.54. So 0.77 minus 0.54. Okay, that's my reaction, and that's going to give me 0.23 volts, I think. कितना होगा 0.23, which is kind of a low potential. I told you previously, E naught cell has to be like really large. So probably it's going to have a very slow reaction. अच्छा ये clear है? इस पे कोई question नहीं है? Is this clear?
Sir,
Minal,
the
जी, जी.
larger the positive value of that indicates the reaction will go faster.
हाँ मतलब वो basically
Okay.
if you go back to the electrochemical cell ना कि the potential between the two electrodes, right? The greater the difference, the faster would be the flow of electrons, right? वो lose करेगा, वो gain करेगा, ठीक है?
Okay.
So the potential difference between the two electrodes, if it's very large, then the reaction is going to be very fast. ठीक है? तो 0.3 के बीच में होगा ना, if it's less than 0.3, then it's probably too less. Like it will still be feasible. I mean, theoretically, it will be feasible. Your highly potential. I mean, reactions don't just depend on potential. There's a lot of other factors which we'll probably discuss related to activation energy. ठीक है? कि खाली एक चीज determine नहीं कर रही होती. There are lots of other factors as well that determine whether the reaction is going to happen or not. So now we're going to move to the difficult example, which is they might ask you. ठीक है? Very few questions, but they can ask you. Or same चीज है. So this is about chain reactions. Okay, so for example, the first example, chain reactions are that if you look at the data booklet, जो कि खुली भी थी यहाँ पे. So if you look at the data booklet, so the problem with the data booklet is that some substances they have multiple oxidation states. For example, Cr goes to 2 plus, right? Oxidizes to 2 plus. Cr can also oxidize to 3 plus. Cr2 plus can be oxidized to Cr3 plus, okay? And that Cr3 plus could be, so that Cr3 plus can be oxidized to Cr plus 6. Cr27 में Cr is plus 6. Okay, so the trouble is a lot of times what happens is when you have multiple oxidation states, if Cr is getting oxidized, and let's say if it wants to go to plus 6, so multiple paths होंगे. It's not going to be, there's no direct path. At least there's no direct equation where chromium could be turned into chromium plus 6. Okay, so chromium might first turn into chromium 2 plus, and then that chromium 2 plus might turn into chromium 3 plus, and then that chromium 3 plus might be oxidized to chromium 6 plus, Cr2O7. So substances have, especially the problem is with substances that have many oxidation states. ये Mn का भी वही issue है. If you look at Mn, manganese turns to Mn2 plus, Mn2 plus turns to Mn3 plus, Mn2 plus also turns to Mn4 plus. और वो चली जा रहा है Mn plus 6, then Mn plus 7. ठीक है, this is Mn plus 4, this is Mn. So basically, Mn से ना Mn plus 7 तक का जो रास्ता है, that would require multiple reactions. I mean, first it will get oxidized to 2 plus, then it might get oxidized to 3 plus, then it might get oxidized to 4 plus, and so on. So it would be like a chain reaction. The whole reaction will not happen in one step, but there'll be many steps. So ये सिर्फ उन्हीं के साथ issue है. Like iodine will not have an issue with this. I mean, this issue will not be with iodine because iodine itself doesn't have multiple oxidation states. Potassium doesn't have multiple oxidation states. तो reaction जो मैं लिख रहा हूँ ना, that is between it's between tin plus iodine. ठीक है? Now, so tin plus iodine. Now iodine, I mean, I just have two reagents, so that's simple. So iodine plus 2 electrons, and that's an equilibrium with 2i minus 1. And it's 0.54 volts. I said, now if you go and have a look at tin, so tin ki, there's just going to be one equation. There's only one place where tin appears in the reactions, that's this one. There's only one place where tin appears, and that's this one. So I'm going to, niche wale mein there's no tin. I'm just going to write this. Tin 2 plus and tin, right? So I'm going to write that. I said 10 2 plus plus यहाँ पे there's 10. क्या value थी? It was minus 0.14 volts. अच्छा, higher potential gains electrons, lower potential. अच्छा, lower potential loses electrons. So out of the reagents, out of the reactants, out of the products. So the first one has the reactant iodine, the second one has tin, and you've got your product which is tin 2 plus 2i minus 1. Okay, and if you want to calculate the E naught cell, that's probably a कर लेते हैं. E naught cell is 0.54 minus reduction potential minus oxidation potential. So that will be 0.68 volts. Okay, so that is fine as well. So that's this over here is step 1. Okay, that's my step one. Because the trouble is, tin has now been oxidized to tin 2 plus. Or let's say there's an additional information in the question that this is in excess. So now, if you have a look at the data booklet, where tin 2 plus is formed, right? But the problem is that tin 2 plus can further be oxidized to tin 4 plus as well. I mean, that's a possibility. Okay? So at the moment, the tin that you had has been turned into, it has been turned into tin 2 plus. That's step number one. So now what you're wondering is whether tin 2 plus can further react or not. Okay? So if I, अब इसको गौर से सुनना, if I, so the product of my first reaction is tin 2 plus. Okay? Tin has been turned into tin 2 plus. And let's say I have still excess iodine left. So I'm going to try and figure out okay, the products that are formed from the first reaction, do they react further or not? So iodine can avoid reaction. It's iodine plus 2 electrons. So let's say that you have the same iodine that's still, some of it might be used, unused left. And the E naught is 0.54 volts. Or tin 2 plus, we know that there is another reaction, right? Okay, tin 2 plus can be oxidized to tin 4 plus. तो हम वो लिख लेते हैं tin 2 plus. And the E naught for that is कितनी E naught थी इसकी tin वाले की? 0.515, right? Okay, so now my starting point is that I've got tin 2 plus. That is my starting point. I've got tin 2 plus. Iodine is the higher potential, it gains electrons, and tin 2 plus is the lower potential, so it loses electrons. So tin 2 plus is still reacting with iodine and it's further getting oxidized. And the electrons are equal, so I can write the overall equation, which is कि भाई वो reactant is tin 2 plus, and the reactant in the first one is iodine, and the product is 2i minus 1 in the first one, and tin 4 plus in the second one. Okay, so after the first reaction, where the first wale mein what happened was that tin got oxidized to tin 2 plus. And then we try to figure out okay, what if this tin 2 plus further reacts with iodine. So I wrote the iodine equation again, and I wrote an equation for tin 2 plus that it can be further oxidized to tin 4 plus, and we figured out that it is happening. So there's reaction number one, and then after that there's reaction number two as well. ठीक है? ये clear है? Is this clear?
Yes.
Ibrahim Hala,
Yes, sir.
middle clear है?
Yes, sir.
अच्छा, so this is what you have to watch out for substances that have multiple oxidation state. कि वो tin 2 plus तक तो चला गया, but what if maybe it will get further oxidized? And the way you're going to write the overall reaction is you're going to add the two steps together. So step one, and after that there is step number two. So you add up the steps. तो अगर add करोगे ना तो it's going to be two iodines. Like if I add both steps. So it's going to be step one plus step two, right? So two iodines plus Sn, and in the bottom there's Sn2 plus. And the product is ऊपर वाले में that's Sn2 plus 2i minus 1. It's actually, or नीचे वाले में क्या it's again 2i minus 1 plus Sn4 plus. Now the same things will get cancelled out. So basically it's Sn plus two iodines, and the product is 4i minus 1 and Sn4 plus. So that is my overall reaction. This is ठीक है? ये clear है? This one.
Yes.
I said, but this was an easy one. There's actually questions that are a lot more difficult as well. This was relatively easy. So for example, I've got a reaction of Fe2 plus. reacting with vanadium. Now, if you have a look at this reaction, इसको एक दफा मैं confirm करूं. Let me just check the oxidation states के ये Fe2 plus. Just 1 second. So loses electrons. The other one has. ऐसे ये B है. ऐसे ये Fe3 plus होना है. 1 second. This is Fe3 plus. So let's try and figure out the reaction between this. So now what I have is these two things. I'm just going to copy the equations. These are the two reagents. The problem is not, it's with both actually. Fe3 plus, there are multiple reactions involving Fe3 plus. Fe3 plus could be converted into, look at vanadium first. Vanadium has multiple oxidation states right at the bottom over here. Okay, all of these equations, they belong to vanadium, and it has multiple reactions. And the same applies to Fe3 plus as well. Okay, if you look at Fe3 plus, so there are multiple reactions, right? It could gain 3 electrons, it could gain 2 electrons. So we've got Fe3 plus. So I'm going to write both of these equations. So quickly, let's say Fe3 plus plus electron. So you get Fe2 plus. And the E naught for this is 0.77 volts, and you've got Fe3 plus 3 electrons. And it's becoming Fe, that's value minus 0.04. I'll just check the values at the end. So for vanadium, I've got V2 plus 2 electrons, and it's in equilibrium with vanadium. And this was 1.20 volts. So और क्या था इधर? अच्छा Fe3 plus हाँ minus 0.04. अच्छा V का क्या है? V has only one reaction, which is the first one, the one that I've highlighted. It's the first one. V or V2 plus, ठीक है? V का सिर्फ there's only one reaction, ठीक है? So you don't have multiple reactions at the moment. So the lowest potential loses electrons. So vanadium is the one that loses electrons, and we do have vanadium, so that's fine. And the highest potential gains electrons, so this is fine as well. ठीक है? We don't have an issue. इसको 2 कर लो ताकि the electrons gain and lost are equal, right? And remember, this is only for balancing. It has no impact on the voltage or the potential. So I've selected the two reactions, highest and lowest. I've got vanadium, I've got Fe3 plus, and they're going to react. So Fe3 plus reacts with vanadium, and the product is 2 Fe2 plus, and the other product is V2 plus. So that is reaction number 1. ठीक है, ये clear है?
Yes.
Yes.
So this is step 1. So now, and let's assume that they've told us that this is in excess. So now I'm going to try and figure out is my Fe3 plus is still in excess. So after the first reaction, what we have in the solution is there might be some unreacted Fe3 plus. I'm going to try and figure out does it further react with V2 plus or not? Okay, that's what I'm trying to figure out. Will there be a further oxidation reaction? So we're just going to Fe3 plus की ना ये equations मैं copy करूँगा, ठीक है? I'm just going to copy these equations. So I'm just going to, and I'm going to see whether V2 plus will get further oxidized or not. ये भी हटा देते हैं. इसको भी हटा दो. So I'm going to figure out what happens to V2 plus. तो अभी फर्स्ट स्टेप तो हो गया, V2 प्लस V जो है ना डॉट टर्न इनटू V2 प्लस. नाउ आई एम ट्राइंग टू फिगर आउट इज will they be further, will it lose more electrons? ठीक है, so ये second वाला V2 plus and V3 plus, that's minus 0.26. पहले वो लिख देते हैं, भूलना चाहिए, minus point. So I've got V3 plus electron and V2 plus. So again, the same thing. Higher potential gains electrons, and this is the lowest potential, so that loses electrons. So we've got another reaction happening, right? That means V2 plus is getting oxidized to V3 plus. The electrons are already balanced, so I'm going to add up the reactants. So reactant के first वाले में it's Fe3 plus. In the second one, it's V2 plus. What are my products? It's ऊपर वाले में it's Fe2 plus. And the bottom one, it's V3 plus. So those are my products, okay? So we did get a reaction, and V2 plus got further oxidized to V3 plus. तो अब वो देखते हैं कि so after this reaction, will there be a further reaction? Maybe there is, maybe there's not. So let's say we still have that excess Fe3 plus, and we're going to see whether it will react with अब क्या बना V3 plus, right? So we're going to see if there's going to be a further reaction with V3 plus. So for Fe, I'm going to copy the same equations. Okay, so I'm copying the same equations, or I'm going to rub this off. Or for V3 plus, okay, so my V2 plus has been further oxidized to V3 plus. Now I've got V3 plus. So I'm going to look for this equation, okay, whether there's going to be a further reaction or not. So this is 0.34, right? So इसकी equation के VO2 plus 2H plus 1. So V3 plus H2O. Okay, let me just double check here. Plus electron 0.34. Plus electron, not 2 electrons. So ठीक है. अच्छा, so this one. So higher potential still gains electrons, so that means Fe3 plus is still the highest one, it's gaining electrons. Who's going to lose electrons? Minus 0.04? Lekin problem है, that requires Fe. We don't have Fe, so I'm just going to cut this out. ठीक है, it was the lowest. Lekin in our reagents we did not have any Fe. I said lowest one कौन सी है? That's this one. So that indicates that there's going to be a further reaction. And the electrons are already balanced, so I'm just going to copy it. The reactants Fe3 plus यहाँ पे क्या है V3 plus H2O, and the product is क्या product बन रहा है? That's Fe2 plus and VO 2 plus 2H plus 1. So we did get a third reaction. Yeah, actual paper में question आया हुआ है. ठीक है, so we are getting a third reaction. इसको थोड़ा शॉर्ट कर लेते हैं कि will there be a fourth reaction? अभी VO2 plus बन चुका है, ठीक है, तो will there be, तो वो ना डायरेक्ट हम यहाँ से भी कर सकते हैं. If you get really good, you don't have to like do all of that. If you practice a lot, ये वाला भी हो गया कि did get oxidized by Fe3 plus, right? So last one देखना है, will that get further oxidized to मतलब VO2 plus बन गया ना now. So we want to figure out whether this will happen or not. And I'm going to tell you this is not going to happen because Fe3 plus का जो potential था ना, that was 0.77. So the highest gains electrons. Since Fe3 plus is 0.77, that is lower than this. So अब इसके बाद Fe3 plus will not be able to gain electrons because this one has the higher potential. So you're not going to have a reaction further. Why? Because ये जो lose करने वाला potential जो है ना, that वो उससे ज्यादा हो गया 0.77 से. As long as Fe3 plus was gaining electrons, right? And as long as it was becoming 0.77, as long as it was 0.77, it was gaining electrons, it was the higher potential, right? It kept on gaining electrons, and these other ones, they kept on losing electrons. Minus 1.2, minus 0.26, 0.34, they kept on losing electrons. V ने पहले electron lose किया V2 plus. V2 plus further lost electron became V3 plus. V3 plus further lost electrons compared to Fe became VO2 plus, but not after that. Because after that, Fe3 plus will not be the higher potential. उसकी potential 1 हो गया इसके बाद तो. So that means the reaction will stop. Fe3 plus will not be able to gain electrons after that. So तीन ही reaction होने थे. So that is all ठीक है. So this was an actual question, and it was just for 3 marks. It's kind of what you had to. Although if you don't copy the equation, you can be quick. Like if the equations are printed in front of you, you can be really quick. You get time to copy करने में लगा था, ठीक है? So you're obviously not copying those equations. Now you want to figure out the overall reaction, so you would have to add up all these 3 reactions together, and that will result in the overall reaction. ये clear है?
Yes.
ये वाला रेयर है कि ये आया हुआ है लेकिन ये क्वेश्चन, ठीक है? And the same, यानी इसको मैं इसमें नहीं कर रहा, the same kind of applies to Fe3 plus and MnO4. MnO4 भी ना, for example, Fe2 plus को oxidize करना है, ठीक है? If you want to oxidize, if it wants to lose electrons, it's 0.77, right? If somebody wants to make it lose electrons, you're going to add an oxidizing agent, let's say MnO4. So MnO4 is like right below this. Now MnO4 can only gain electrons if it's the higher potential. So ये MnO4 है, and 1.67 volts, it has the higher potential, so it will gain electrons, right? Because it's the higher potential, right? And it will form MnO2. Now the trouble is, कि अब MnO2 बन गए, and MnO2 is still the higher potential, so इसका मतलब MnO2 will still again gain electrons, and it will further get reduced. वो Fe2 plus electrons lose करता रहेगा, and these will continue to gain electrons. MnO4 will gain electrons to form MnO2, and then that MnO2 will further gain electrons to become Mn2 plus because it's still the higher potential, right? So higher, this is also higher, and that is the lower one, so the reaction is continuing. Now when it becomes Mn2 plus, Mn2 plus can gain electrons to become Mn, but that will not happen because यहाँ पे ना the potential is too negative. It had to be the higher potential to gain electrons, so which is why a further reduction is not going to happen, because if it comes to gaining electrons, you have to be the higher potential. So as long as you are the higher potential, you will continue to gain electrons. और वो आपकी जितनी भी stages है ना कि MnO4 +7 था, it turned to +4, and then that +4 gained electrons to become M+2, but then Mn+2 will not be able to gain electrons क्योंकि it is not the higher potential, it's -1.18, ठीक है? तो ये clear है?
सर इसका क्या मतलब है, लाइक Mn4 पे 2 प्लस नहीं रहेगा?
नहीं जाएगा, क्योंकि गेन करने के लिए क्या होता है कि आपको हायर पोटेंशियल होना चाहिए ना.
ओके.
मतलब वो रिएक्ट किस साथ कर रहा है? 0.77 के साथ ना. Fe2 प्लस इलेक्ट्रॉन दे रहा है, वो लूज कर रहा है, तो MnO4 इलेक्ट्रॉन गेन कर रहा है, इट्स बिकमिंग MnO2, and MnO2 is still the higher potential, so MnO2 gains more electrons, becomes Mn2 plus. But Mn2 plus cannot gain more electrons because वो -1.18 आ जाता है. वो Fe बेचारा 0.77 है, वो उससे ज्यादा हाई है ना, तो Mn2 plus उससे कितना इलेक्ट्रॉन गेन कर सकता है? बात समझ आई?
यस सर.
ठीक है, तो लोअर ने लूज करना है, हायर ने गेन करना है, तो हायर तभी गेन करेगा जब वो हायर होगा. अगर तो वो हायर ही नहीं है तो वो गेन कर ही नहीं सकता उससे. तो ये जो रिएक्शन है ना, 2 स्टेप्स तक होगा. Fe2 plus will turn to Fe3 plus, and it will lose electrons because it's the lower potential. MnO4 will gain electrons, and it will then again further gain electrons. ये दोनों केसेस में it is the higher potential, लेकिन only till Mn2 plus. ठीक है, ये चीज क्लियर है?
यस सर.
तो याद रखना ये क्वेश्चन जो है ना बड़ा रेयर है, लेकिन ज्यादातर टाइम क्वेश्चन होगा इट्स गोइंग बी वेरी सिंपल. यू जस्ट हैव टू इलेक्ट्रोड्स, दैट्स इट. किसना वो बीच में नहीं आयोडीन और के है, वो पूछ लेगा व्हाट इज द रिएक्शन. तो आयोडीन और के में क्या है, दे डोंट हैव मल्टीपल ऑक्सीडेशन स्टेट्स, तो रिएक्शन इज वेरी सिंपल. कि वो आयोडीन वाला हायर पोटेंशियल है, सो आयोडीन गेन्स इलेक्ट्रॉन्स एंड के इज द लोअर पोटेंशियल, सो के लूजेस इलेक्ट्रॉन्स, दैट्स इट. So most of the time you're going to get a very simple question. ये कभी कभार ना randomly बीच में ना they give this question where you have multiple successive reactions. तो चलो ठीक है, नेक्स्ट क्लास पे कंटिन्यू करते हैं, ठीक है.
अल्लाह हाफिज़.
ओके, अल्लाह हाफिज़.